Assalamualaikum and hi everyone! Welcome to our video presentation. We are from Group 10 and we're going to discuss a very interesting topic in this digital era, which is pros and cons of too much or too little data. Before we begin the discussion, let me introduce our team members. Our team consists of 6 members. We have Shafiq Danish, Nurul Ain, Haidri Siddiqui, Aidil, Lutfan Farihin, and myself, Shahida. Now, let's jump straight into the introduction. Actuaries rely heavily on data to assess risk and price insurance products. However, both excessive and insufficient data can create challenges. This raises the questions of how much data is actually beneficial for actual decision making.
Big data is defined as datasets that are so large, varied, and fast-moving that regular software tools cannot easily store or analyze them. Meanwhile, small data consists of limited amounts of information that are usually collected in a very controlled way to answer a specific question. But this has sparked a major debate: big data versus small data. On one side, big data fans believe more is better. They argue that tracking an entire population where n equals all cancel out errors and reveal universal truth. On the other side, critics call this magical thinking. Big data is often just a messy byproduct of digital system, not a tool designed for a specific job. In fact, a small high-quality sample frequently outperforms a mountain of low-quality data. Most importantly, by optimizing for the average person, big data completely erase the unique story of minority group who don't fit the main trend. To understand this friction, look at how they operate. As shown on the slide, big data is exhaustive, operational, and accept high messiness for sheer volume. Small data is a sample base, strictly designed for a specific problem, and must be pristine to hold statistical weight. Ultimately, big data gives us the broad macroscopic trends, while small data captures deep microscopic individual narratives. The critical problem is that we lack a bridge between these two worlds. Today's data-hungry AI models fails on a small dataset due to overfitting, noise, and sampling bias. This leaves a specialized fields like rare disease research completely stranded because massive dataset doesn't exist and high-quality label data is too expensive to find. To make matters worse, there is a language barrier. Computer scientists in big data and mathematicians in small data are simply not speaking the same language. Moving forward, our goal shouldn't be choosing one over the other. The future of robust modeling relies on a building technical bridge, using statistical methods to handle uncertainty and transfer knowledge, ensuring that even when data is small, our insights remain powerful, accurate, and inclusive.
Some factors that can contribute to too much data are the widespread use of tracking tools and smart devices such as fitness trackers and social media accounts that we can easily look at, alternative data sources such as credit scores, or modern tools and methods such as machine learning, generalized linear models, and Bayesian methods that encourage actuaries to get too much data. On the other hand, the launch of new insurance markets and fresh product lines creates uncertainty since there is no past history to look at. Secondly, the modeling of rare but catastrophic events such as private health insurance or catastrophe modeling has too little or too unpredictable data since these events happen irregularly. Finally, strict privacy laws put a limit on how much data companies can get while still protecting the customer's privacy, and separated company systems force actuaries to look at public data or make guesses about the model.
Next, I will explain the impact of having too much or too little data on companies, countries, and community. For companies, especially insurance companies, having sufficient and high-quality data can improve risk assessment and pricing accuracy. It also helps companies develop more personalized products and increase operational efficiency. However, having too much data may increase storage and processing the cost. It can also create privacy and cybersecurity risks. On the other hand, having too little data may lead to inaccurate pricing, poor risk estimation, and financial losses. At the country level, data supports evidence-based policy making and strengthens the stability of financial and insurance markets. It also encourages innovation and contributes to economic growth. However, excessive data collection may raise concerns about privacy and data protections. If data is misused, public trust in government institutions may decrease. Meanwhile, insufficient data can make it difficult for policymakers to make effective decisions. For communities, responsible use of data can lead to a fairer insurance pricing, better public services, and improved disaster preparedness. It also increases awareness of data privacy and digital literacy. Nevertheless, excessive use to personal data may create privacy concerns and ethical issues. There is also a risk of algorithmic bias, which may lead to unfair treatment of certain groups. In addition, limited data may result in inaccurate risk assessment.
Hi, I'm Lufan Farihin. For my part, I will explain the approaches taken by different parties on the issues of too much or too little data. First, individuals such as actuaries and data analysts should use data critically. They should not assume that more data is always better. Instead, they need to check whether the data is relevant, reliable, and suitable for the model. When data is limited, actuaries can use methods such as credibility theory to combine limited experience with the broader data. At the same time, they must protect customer privacy and use professional judgment. For companies, the main approach is to strengthen data governance. This means companies must manage data quality, security, and proper usage. They should clean and validate data before using in actuarial models. Companies should also avoid collecting unnecessary personal data because this can increase privacy concerns. Model testing is also important to reduce risks such as overfitting, bias, and unfair pricing. At the country level, governments and regulators have an important role in controlling how data is collected, stored, and used. Data protection laws help ensure that companies only collect data for clear and lawful purposes. Regulators can also make sure that the big data and machine learning are used fairly in insurance. Besides that, governments can provide public data sets such as population, health, accident, or climate data to help actuaries when company data is limited. Finally, communities also play a role. The public should be aware of how their personal data may be used in insurance pricing and underwriting. Community groups can raise concerns if data is used unfairly or causes discrimination. Communities can also support better data collection by participating in surveys or local risk studies. Overall, these approaches show that the issue should be managed through balanced, ethical, and responsible data use, not simply by collecting more data.
My name is Muhammad Aidil. In this section, I will discuss what we have learned from actuarial knowledge regarding the issue of having too much or too little data. Firstly, the law of large numbers teach us that larger datasets generally help actuary make more accurate risk estimate, because actual claim experience become closer to expected outcome. However, this issue also shows that the more data does not always mean better decision. Large dataset may contain irrelevant information and data noise, which can make it difficult to identify the factor that truly affect risk. Therefore, actuaries must focus on selecting meaningful and relevant data rather than simply collecting more data. Secondly, we learn about overfitting and modern risk management. Modern actuarial model can become very complex and fit historical data too closely. When this happens, the model may perform well on past data but produce inaccurate prediction for future events. To reduce this risk, actuaries use validation techniques such as a back testing and sensitivity analysis to ensure that model remain reliable and suitable for decision making. Besides dealing with excessive data, actuaries also face situations where there is insufficient data available. In this situation, credibility theory becomes important because it allows actuaries to become internal company data with external industry data to produce more reliable estimates. This has improved pricing, reserving, and risk assessment decisions, especially for new insurance product or rare event where historical data is limited. Another important lesson is the importance of data governance, ethics, and professional responsibility. Actuaries often work with sensitive customer information, so they must ensure that data is collected and used responsibly. Privacy, fairness, transparency, and accountability are essential to maintain public trust and avoid misuse of personal information. In conclusion, this issue teaches us that successful actuary practice is not determined by the amount of data alone. Instead, it depends on using the right data, applying appropriate actuary method, and maintaining ethical standards in decision making.
To manage data imbalance, actuaries should validate models regularly, use credibility theory when data is scarce, and maintain strong governance to ensure data quality, security, and ethical use. In conclusion, both data abundance and data scarcity present challenges in actuarial practice. The key is not simply collecting more data, but ensuring that the data used is relevant, reliable, and ethically managed to support sound actuarial decisions.